Hi, I'm Sam Nolan, sales engineer with nexAir. Today we're going to be looking at some of the dynamics of the different weld gases. So we're going to start with CO2. Carbon dioxide is one of the most used weld gases and is used on everything from flux core welding to MIG. To start with, we're going to focus on short arc MIG processes for all the gases we're going to discuss. So I've hooked up my bottle of CO2, the regulator's on and set, and we're going to go ahead and get welding. CO2 is a harsh gas. It's one we can expect a lot of spatter as well as some deep penetration. So pay close attention to the arc dynamics as we weld. Eyeballs. That's your standard CO2 weld. There may be a little more spatter than normal, but there is a lot of spatter expected with this gas. You'll notice your weld bead is very convex with very distinct toe lines and very little wet in at the toes. This is characteristic of CO2. So seeing what CO2 does, it's important to make a few notes. CO2, because of the deep penetration, is not recommended on thin materials. Even though it is a less expensive gas, you're going to have a lot of burn through and a lot of cleanup to take care of on the back end. For thinner gauges, we recommend more argon, which is what we're going to move to next. Because of the thermal properties of CO2, as well as its properties as an ionization gas, it's important to remember CO2 will always be set at a much higher voltage than your other gases. So since we're moving to pure argon, what we're going to have to do is turn this down. We're going to go all the way from 24 volts with the CO2 to 18.5 with the pure argon. So with pure argon, it's important to remember this isn't really a gas designed for short arc welding. While it does work, it actually has better properties in spray transfer than in short arc. So pay close attention to the differences. You're going to see more of a fast freeze than you did with the CO2. Eyeballs. You'll notice the weld looks very different than the one for CO2. Aside from the shape, which is far more wet out on the edges, it's not as convex as the CO2 weld was. You'll also see that the heat line along the edge of the weld extends much further in the argon gas than it did in the CO2. These are important aspects to remember when you're planning a welding project, and it's why we tend to use mixed gases where they contain different amounts of CO2 and argon. So next we're going to look at 75-25, one of the best gases for short arc welding. Since we're moving from the pure argon to the 75-25, it's important to remember we're going to have to make some changes to our settings. For this, we went up in our voltage to ensure that we get in between the argon settings and the CO2. We also dropped our amperage because of the way the two gases react together in the arc. So what we need to do now is to go ahead and strike an arc. It's important to remember the sound you're going to hear as opposed to CO2 and argon is going to be much closer to the frying bacon crackle that everybody's used to. So, eyeballs. You'll notice this weld combines the properties of the two different gases. Where argon has an extreme wet out line, the 75-25, while it has a wet out line, it's not quite as extreme, nor is the heat affected zone. You also get much more convex, closer to what you see with the CO2. You'll also notice, however, that spatter did increase when we went to the 75-25. Since we've done the 75-25 weld, let's look at what happens when we add more argon. It's important to note that above 80% argon, we have the ability to go into what we call spray transfer. So what we're going to run next is a 90-10. We're going to run it as a short arc gas, but then we'll take a look at what differences happen when you increase your settings to try to get into spray. So now we're going to move on to our 90-10 gas. 90-10 is 90% argon, 10% CO2. So it's only got a little bit of it in there, but it's going to make a dramatic difference over the pure argon. So to get started, we're going to focus on the short arc weld with this gas. It should be fairly similar to 75-25, but you're going to see a slight difference. Eyeballs. So with the 90-10 gas, you'll see something much closer to what we had with pure argon. You'll see that the tow lines are very, very well wetted into the surface. You also have, though it does have some concavity, it is fairly flat. There's also less spatter, more sand spatter, less globular spatter. But this is in short arc. From short arc mode, we have to look at other properties. We can go all the way from the short arc to the globular to spray. So let's go to globular. So the important thing to remember about globular transfer is that the wire actually changes the way it operates. Instead of going into the weld puddle and shorting out, like in short arc, it actually creates a molten ball of metal bigger than the diameter of the wire. So what we see in the end are large pieces of globular spatter, but still a pretty good weld bead. You also, on the tip of your nozzle, end up with one of the beads stuck on. This is the best indicator that you're in globular transfer mode, is when you end up with the end of the wire looking like that. However, globular has its place. Unlike short arc, it has a very high deposition rate for weld wires, and it can go out of position. However, spray, which gives you high depositions, can't always go out of position. So globular is fantastic if you've got to get a lot of metal in all different positions. Settings for globular transfer usually range between 24 and 25 volts. So what we have is globular settings. When we want to go to spray, we need to increase our voltage to about 26. And we're going to increase our wire feed speed to just over 350. This should give us a fairly good spray transfer. And so we're going to go ahead and give a nice clean spray weld. Spray transfer is all about giving high deposition rates with high rates of travel and providing a good clean weld. And so let's go ahead and get started and compare this to what we've been doing so far. Eyeballs. You'll notice on a spray bead it's much smoother than those of short arc. If you're watching the travel speed, I was really moving compared to what I was doing before. So you get a nice wet weld. However, as I said, this cannot go out of position. You'll end up pouring metal off onto yourself. And so it's got to be something used in the flat position only. So it's important to note that this doesn't only apply to manual welding. These 4 parts were made with the same 4 gases, same settings on a robotic welder. So each one will have the exact same weld done with the different gases. We see we have the same properties that we had, the shape of the weld, the heat zone, the way the tow line falls, as well as the spatter that we had in the manual welds, but they're the perfect clean robotic. And so no matter what welding machine you're using, it's important to remember your gas choice makes a difference. So the information we covered today just covers your basic gases for mild steel. Whether you're welding stainless, aluminum, there's a lot of options. It's very important to make sure that the gases for your process are optimized for what you're doing. So be sure and speak with your local welding representative to ensure that you get the gases you need for the process you have. So I hope everyone found this really useful and have a great day.